Robots. One of the first things that probably comes to mind is that they're made with wires and metal and bulky electronics. They might be able to mimic biological behavior, but they don't actually function like humans or like animals. I'm here to introduce robots that are the exact opposite of that. These robots can mimic human and animal behavior with artificial muscles. And most importantly, they don't need fancy electronics. Welcome to the world of soft robotics. Firstly, soft robots' main driving force is that they function with muscles. These artificial muscles are usually powered by a pneumatic system. Although referred to as muscles, they don't actually function like real muscles. Real muscles don't take in air or any material to inflate themselves. Muscles contract with something called an action potential. And surprisingly, engineers were actually able to replicate this in two different ways. One group developed an almost exact copy of the human musculoskeletal system that behaves like a real one, using microfibers that contract when heat is applied. Another group developed a system of plastic bags filled with vegetable oil with electrodes connected to them. When electricity is passed through the electrodes and into the oil, it causes all of the oil to group together, causing a contraction. In this case, the action potential are the electrodes. Some other benefits to soft robots is that due to the materials that they are made with, they are cold resistant, heat resistant, and impact resistant. They are able to run after being run over with a car and keep moving afterwards. Their material also makes them waterproof, which allows engineers and scientists to create lightweight artificial fish and octopuses. So that's just a little brief description on what soft robotics are and what their advancements have been. So now let me talk about how I went about creating one. I first began by sketching out my hand. I wanted to create a soft robot hand that was approximately the size of my hand, so I took measurements from my fingers. Once I had a general sketch done, I went on to Onshape to add my designs. I went through 3 versions of molds for the hand. Since I was going to make it with silicone, I needed a mold so that I can pour the silicone into it to create the hand. So the first version was just like for a finger, and the final version ended up looking almost like a claw of sorts. So after I had my final version, I exported my design into Cura software, which is a software that I use to slice my objects, which is what is required to make something 3D printable. So once I had it in Cura, I had to scale down the piece to 93% instead of 100 because my printer was a little bit smaller than I expected. And then I zeroed it. I then noticed that it was going to take 1 day, 16 hours, and 17 minutes to print. I then downloaded the file to my drive and put it into the printer. Once the mold was done, I had noticed that I had made the walls a bit thin, so I feared that the hand would pop when inflated. So I had to create another mold, but I didn't have enough time to 3D print another one due to the fact that the last one lasted almost 2 days to print. So I decided to create a cardboard mold. I knew it would work because the EcoFlex would only stick to itself, so I quickly made one as fast as possible, and I also changed up the design a bit. From 4 fingers, I switched the design to 3. I switched the design to be more than a fish spine. Once I had my molds completed, I used EcoFlex, which is a type of silicone that is softer than skin that doesn't stick to anything but itself. So I filled in the molds and waited for 4 hours, till the silicone hardened. Once it was ready, I just peeled out the silicone pieces and I then created spontaneous molds of hot glue, since I didn't have time to 3D print one, with a 1/4 of an inch offset from the original piece to kind of create a little exterior. And I then casted those in EcoFlex. So once I had both pieces, I was finally able to stick them together. I also had to check for any holes or punctures due to the fact that if there is one, I would have to apply EcoFlex and wait another 4 hours to test it out. So once I checked all the holes, made sure to patch them up with the EcoFlex, I was finally able to add tubing into them to test them out. So through testing, I popped one, and one of them just moved one arm. So I only really got to get one to work. Thank you for watching.